Hello friends, this is Barun Das. So today I want to share a few aspects of the wonder material graphene, which is been around in academia and research area metal science for more than a decade or so. And I think everybody knows by virtue of that research activities published worldwide what is graphene, what are its aspects, what are the fantastic behavior and nature characteristic. So everybody knows about that. I'm not going to talk about that on that today. So I will emphasize mostly how graphene can be utilized in civil engineering applications. Civil engineering means for reinforcing building material like concretes or cement, how it can also reinforce so real-time concrete material or cement. So it's mostly for the people who are interested or who are doing research in civil engineering. For them, it will be useful. And I'm a just chemistry. I'm from the chemistry background. My core competence is chemistry, so I understand chemistry. So I'll try to just correlate the chemistry aspect and try to correlate with the civil engineering aspect a little bit. People are doing actively research on civil engineering on this topic, reinforcing concrete and cement. They might be interested by looking at this video. So to start or begin with, I will first want to highlight one article, interesting article I found published in the year 2005 by Sobolov et al. What they did, they used functionalized graphene oxide, they name it as FGO abbreviated form, just to reinforce the cement, mechanical reinforcement of cement. What I understand from the term functionalized graphene oxide, it is something different from the conventional graphene oxide or GO, which has been around for at least more than 10 years or so, and everybody's aware of that. What is GO or graphene oxide? Graphene oxide and GO, as everybody knows, can be prepared by a conventional Hammers or modified Hammers method, and it is one of the bulk procedure to synthesize graphene kind material by wet synthesis or chemical synthesis. And it has characteristic oxygen functional group like keto, epoxy, or carboxylic group on its surface. By virtue of it is quite water soluble, can interact by hydrogen bonding. What I understand from the term FG or functionalized graphene oxide, what this guy is mentioned or used, is some kind of engineered graphene oxide. So I think they synthesize graphene oxide and further functionalize, or they somehow modify the Hammers method to have their unique characteristic functionalizations on the graphene oxide surface so that it will be compatible in terms of the chemical interaction. Compatible means in terms of the chemical interaction, so that it is able to interact the chemical component or different chemical component present in the cement or concrete component, concrete material. And what they say, different features or characteristic of this functional graphene oxide is as similar as of the geo, this quite water soluble material like geo, large surface area, which is quite obvious, and that's why it is able to build a strong bond or connection between the graphene and the hydrate component of the cement, maybe silicon dioxide hydrate or silicon hydrate, something like that, by covalent bond, or it might be non-covalent interaction also. I strongly believe, and there's a lot of literature available, like graphene oxide or functionalized graphene oxide is able to bind with different material starting from polymers, which is having a lot of hydroxyl carboxylic functional group by virtue of weak interactions such as Van der interactions or hydrogen bonding interactions. So I think similar kind of phenomenon is happening here. It might not be covalent bond, it might be some weak interaction or hydrogen bond kind of interaction, and through that it is nicely bond to the cement hydrate components with the graphene. There's a strong bond formation or bonding between the graphene domains and the cement hydrate components, and that's why it is enabling high tensile strength high compressive strength, and there is also less shrinkage due to the high stability of graphene also they mentioned. So these are some key features uh, which they found, and I think they did their postulate while they use FGO as a mechanical reinforcing material rather than GO. Later part of this presentation or report we'll see why they use FGO or functionalized graphene oxide rather than GO. I think they have some clear-cut evidences. In later stage, you will see that. If you use GO, what is the impact? Or if you use FGO, what is the output? Let's move on the next slide. Let's see what they observed or found when they mix FGO with cement. And one can see that is very common SCM micrographic images or evidences. They examine the surfaces of that FGO cement composite. So at the stimulate we can see the least magnified images, and they keep on magnify, and they got something interesting, and which is nothing but some kind of crystal formation of the cement component. And they found that happened within 10 minutes, which is very interesting. And what they observed conclude, and it's quite evident also, makes sense also, like what I understand, I think everybody will be the same page with me also, like this graphene surface is now acting as a potential nucleation site for the growth of the cement hydrate crystals. Like cement has, to best of my knowledge, have a lot of silicon dioxide, silica, alumina, and other kind of oxide component. It's not a single component system. So those hydride start forming or start growing as a crystal or needle type crystal on the graphene surface, and which is quite well understood. Even I did also some of the studies in my PhD days. I found the similar stuff. And graphene surface, which is high surface area, is quite helpful in growing this kind of crystal. I think that is the reason that graphene surface is catalyzing the crystal growth formation of the cement hydrate composite or components, and also they are tightly bound with a bond with the graphene surface. These are the crystal which is growing on the graphene surface, and there's a good interaction by means of some kind of covalent or non-covalent interactions like hydrogen bond. So eventually you will end up with a very good connection or bonding between the graphene surface, which is nothing but a filler material in this composite, as well as with the cement hydrate spaces. So that is the benefit they found when they use FGO, which is nothing but acting as a nucleation site for the further crystal growth, and the large amount of crystal which is from that is actually helping in hardening process, what they understand. So that is their speculations after getting the SM images. One thing I must say in this case, like graphene was and still and will be also continuously used as a filler material or nanofiller material in any kind of matrix, maybe as a polymer matrix or inorganic matrix or organic matrix, for reinforcing different kind of properties or aspect like mechanical, thermal, or electrical. I think when you talk about the civil engineering or building application material, definitely mechanical reinforce would be the key factor. And in this case, we have 1,000 of literature in the past 10 years or more, which shows like graphene oxide and graphene kind of material with proper functionalization can act as a potential filler material in reinforcing mechanical strength of the polymer matrix or other matrix composites. So basically, when you mix FGO, functional graphene oxide, or cement or concrete, basically it's nothing but a composite. It's like a cementous or cement or concrete composite, where the cement or concrete is a matrix and graphene is just a filler material to enhance the mechanical property. And here, graphene, how is reinforcing happening? I think it's a clear-cut SEM observational evidences. Like graphene oxide surfaces act as a potential site for the nucleations of this cement hydrate component crystal, and they keep on grow, and there's a good connection, and due to these good connections there's also densification, and that leads to the high mechanical property. And you know, like any crystalline material will be having much more higher strength or tensile strength than the amorphous one. There's no doubt about that. So when something is forming in the form of crystal and there's good connections with the filler material, definitely one would expect the much better mechanical reinforcement than the control sample where the nanofiller is not added. So impact will be much more higher. So let's move on. So there is a clear-cut evidences. They measure the mechanical strength. One is compressive strength in megapascal unit. One is flexural strength. And all the black histogram in both the curve or black bar is a control sample, like sample without FGO, only cement. And the red one is the composite sample, like FGO, which is present is 0.1 weight% of FGO in cement. So red one is the composite sample with 0.15 weight% of FGO in cement, and black is the control sample. And one could clearly see with respect to control there is an enhancement, and they also quantify it. It's clearly understood, self-explanatory. And also if you see x-axis, there is a time axis which is days after casting for both the cases. And as you can see, as you keep on increase the date, like it starts from the 3 days to 28 days, means almost a month for both the cases, the compressive strength keep on increases, as well as flexural, same behavior is observed. This means this is quite good indication, I think so. Because when you mix two components, like in this case the matrix is a cement or concrete, which is the inorganic, and graphene is a carbonaceous material, and functional graphene oxide is a filler material, and definitely there's a good connectivity, and crystal is forming, and it's quite stable. That's why it is keep on cross-linking kind of behavior is happening, like it is kind of making cross-linked network with graphene, like cementous composite or component in cement is making some cross-linking network with graphene, looks like, if we try to understand the mechanistic way or mechanism. And that's why it's keep on stabilizing and enhancing thereby the compressive strength. I strongly believe at some certain point it will definitely saturate, but it's not degrading. That's a good point. So this mixture of compositions or formula is definitely stable. It is indirectly proving. So FGO is quite compatible with the cementous composite. It's not phase segregations or no decrease or deteriorations of this property. So that is also a quite crucial point. That's why they want to show this one. So it is a quite interesting and impressive result they found, and encouraging for the future researcher working in this area. And they also got some comparative number when similar kind of study was performed by them or somebody else with 3% of silicon nanoparticles. There is a 16% improve in the compressive strength, where we got a 44%, almost close to 50%, if you add only 0.1% of FGO rather than the 3% of the silicon nanoparticle. And I must say they also shown like they've added also pure geo without functionalized geo, like a geo prepared by Hammersmith, I strongly believe, with 0.45 weight% of geo addition or pure geo addition in the cement, they got only 5% improvement. So definitely FGO has some effect, shows definitely some effect over the silicon nanoparticle as well as with respect to the pure geo material. Same thing is observed for the flexural strength, where 0.15 weight% of the FGO additions leads to a fractional strength improved by a 20% value, where they got the 6% improve in the fractional strength when they add the 0.458% POGO. So this definitely implies FGO is much more effective in reinforcing cementous composite or cement or concrete material than the conventional silica nanoparticle inorganic fillers as well as POGO. So FGO has definitely unique features than GONN. Let's move on to the next slide. And it is quite self-explanatory slide, I strongly believe. Uh, on the top panel, you can see the SEM micrograph images, starting with the low mag and keep on increase the magnification. And this is the reference, the plain cement without any nanofiller or graphene. And down the same thing, they took SEM images or captured SEM images with 0.158% of the FGO. Clear-cut differences is there. If you can see, or one can see the top panel, there is a creation of definite voids, which is evident at the low as well as high mag, where you use the 0.158% of FGO, only 0.158% of the FGO, which is less than a percent. That is enough to not only enhance the compressive strength and fractional strength by few order magnitudes than the control, as well as when you put the conventional silicon nanoparticles or POGO, as well as it is densifying the structures. No void is seen. So that is the secondary reason. So graphene surface, I think so, or functionalized graphene or FGO surface not only is acting as a potential site for nucleations so that the cement hydrate crystals start growing, and that helps in the further crystal growth, and there's a good bonding connections by virtue of the covalent or hydrogen bonding interaction. Also there is a densification. So this multiple effect, I strongly believe this leads to the improvement or significant enhancement in the flexural modulus, tensile strength in this kind of mechanical property of the cementous material. And one thing is very evident, FGO is much more effective than GO as well as with the conventional silica nanoparticle as inorganic nanofiller. And also one point is very crucial that we should keep in mind, we need very low percentage of this graphene oxide. So it is also very cost effective and economic solution. Less than a percent, 0.158% is enough to improve this kind of, to get an improvement in this mechanical properties like frictional modulus and tensile strength. So you need a very low dosage of nanofiller addition or graphene addition or FG addition in order to get a similar or much better higher improvement in the mechanical property. So this is quite interesting and motivating. Another relevant article I got when it was published in the year of 2017, 3 years back, in Nanomaterials and Nanotechnology. I think it's kind of review kind of article or highlight whether they gather all the data, and you can see from the title it's quite encouraging. The graphene engineer cementous composite small makes a big impact by Zhang et al. Looks like from China, I'm not very sure. And in this particular article they have given this kind of summarized result, and I think 4 or 5 dozens of paper references. I think people actively working in this area for material science, materials engineering, civil engineering or chemistry are in a collaborative program among this discipline. That might be helpful or very useful, this review, where they get or they will have the access all this kind of references, where is a one-page summary or gist. What are the different kind of graphene material they use? Like, I think people generally use graphene nanoplatelets as well as graphene oxide material, some kind of graphene functionalized graphene oxide material. So GNP, GON, last we encountered FGO material. And they have measured different kind of mechanical properties starting from hardness, tensile strength, compressive strength, frictional strength, ductility, etc., etc. And also people have varied the concentration or dosage of the GNP and GO material as a filler, and most of the cases we see, I think in majority of the cases, 99% of the cases, the dosage is, as I mentioned earlier also, less than 1%. So that is quite important. So it is possible because graphene is high surface area material, is a nanomaterial. So surface area volume ratio is very high. So in a matrix, maybe it's an organic matrix, or is a polymer matrix or organic matrix, or in a cementous or concrete matrix, due to by virtue of this high surface area and unique functionalizations, it is able to interact very effectively with the surface of the matrix, eventually leads to a very good bonding or connection by virtue of covalent non-covalent interactions, as well as can help us by virtue of the high surface area as a potential point of nucleation and growth of the crystals. And definitely there's also densification. So this combined effect, again I am emphasizing this is not a single effect, it's a combined effect. This graphene materials is become or seems to be very effective in improving the mechanical properties of this cementous composite. And I think one should go through in details of this particular review and get all the references if they're interested. I just give a overview and my understanding. Those who are interested in this area or actively doing research, there are plenty of encouraging results already present in the literature. Another relevant article I have encountered when I got this journal called Sustainability, where they have done some studies. I will come to the next slide, and the title is also very interesting: a sustainable graphene-based cement composite, by some of the group of researchers from civil engineering department from Malaysia, different universities from Malaysia, Kazakhstan. So it's like a Pakistan, all the Asian countries. So it's like a collaborative kind of programs for all the Asian countries from Malaysia, Kazakhstan. Good to know that everybody is engaged worldwide also in this kind of discipline like civil engineering, and different countries people are interested, and in future also people are interested to explore the fascinating properties of this material, and they're also doing actively research in order to get impressive economic way to improve the performance of the available conventional cement and concrete composite. So that is very encouraging. Let's see what they have done. So they have used graphene nanoplatelets of this specification of the average size or lateral size is around 4.5 micron or 4500 nanometer, almost 12 layers, not 12 nanometers, 30 to 50 monolayers. So it's quite thin and large lateral size. That is very good, and due to this large lateral size, it has a very high surface area, 80 meters square per gram, and it's quite pure from 99.2, almost 99%. So it is quite thin graphene, high surface area, high lateral size, and high purity. So this specific, this grade of graphene nanoplatelets or graphene material they used, and they call it as a graphene nanoplatelets. First example we have encountered they use a special graphene oxide or engineered graphene oxide, I would say, or functionalized graphene oxide. Now this shows also the researcher in this area, like in this discipline, civil engineering discipline, also used GNP or graphene nanoplatelets, which is very thin in nature and also large in size. Also utilize, exploit this material in order to get improvement the mechanical property of the cement or concrete composites. So their key result is this. You can see this table is very simple one. They have made the 4 different compositions or mixing or formulations. One is M0 and GM3, GM5, GM10. M0 is the compositions or formula where they used only cement and water. They didn't use any GNP. GNP percentage, as you can see, is 0. So it's like a control sample. And rest of the 3 sample, they have used cement, water, and GNP. And GM3 means 0.03% of GNP, and GM5 means 0.05, and GM10 means 0.1. I think the least percentage of GNP or graphene material they use is 0.03, which is nothing but GM3, and highest they have used 0.1. So again, I am emphasizing on this fact, like one need to use the graphene material very, very low dosage, so less than 1%. So that's why it became much more economic and cost effective in terms of the commercialization point of view, business point of view, as well as it will have a much higher or better or similar. Always, most of the cases, I would say it will have a higher impact in terms of the improvement of the mechanical property. And they also got the same result. So they measured the stress strain curve. As all of us know, like the stress strain curve is a curve where we can get the yield strength, where the elastic plastic regions transitions. So this region is the elastic regions, and there is yield strength, and there is a permanent deformation or breaking. So M0 is the red color curve, and blue is GM3, where they use 0.03 very minute dosage of GNP in cement, and M0 they have used no graphene like as a control. And definitely you can see by adding 0.03% of GNPs is enough to improve this yield strength or increase or extend this elastic region. That means you require more higher strain or force to break this composite. So definitely is compressive strength, overall performance of the cementous composite increases by adding a very minute dosage. So that enables us to give a very economic and efficient solution in order to monitor or design or develop a good cementous or concrete composite with graphene. So that is again proving the same story, like graphene material is quite effective in terms of improving the mechanical property. So this is the last slide, and I am not going to discuss on that. So you can get a lot of example, a lot of references relevant people or students working in this area in civil engineering department or chemistry department in some colleges or local universities, or have some plan to do this kind of study, whether graphene material or different kind of or different grades of graphene material are really, or whether they at all is effective in terms of the reinforcement of the cementous or concrete composite. I think there is a huge opportunities there. Already a lot of studies has been made. So this is one of the example or the article I encountered where they use the functionalized graphene for reinforcement of cement as well as reinforcement of steel, not only cement. So it is also shows some promising behavior for the reinforcement of the alloys also, like steel. Steel is nothing but the alloy. To best of my knowledge, I think Tata Steel R&D somewhere in Europe, they are doing some research in this area where they have started exploiting graphene in terms of reinforcing the mechanical property of the steel. So not only graphene can reinforce the cement or concrete composite, also it can reinforce the steel. So steel also is the inevitable part of a building material for civil engineering or mechanical or structural engineering. I don't know what to say the correct way. This is also the inevitable part. So cement, brick, steel is all inevitable part for any kind of construction. So it might be very interesting or helpful to see whether it can enforce also the steel. So overall, the results are quite promising. There are already some reports are there. This is the report from Chalmers, the recent one, what I'm showing in the present slide. So I think it is a good overview. Whatever I understand from a chemistry perspective and superficial knowledge from civil mechanical engineering point of view, what I understand, like this material, this graphene or functional graphene material definitely has a promising career in future in building material applications also, in terms of reinforcement of cement as well as concrete as well as steel. So people are actively doing research in this area, will be much more interested in this topic. They can definitely go through all these articles shown by me and all the back references, and definitely it will be useful for them. So thank you very much for your kind attention. For any question and answer, you please post in the comment sections of the video. Thank you for watching. If you like, kindly share and subscribe. See you later. Good night. Bye. Thank you once again.